So today we have three geometrical questions. The reason to bring all of them together is that they have the same strategy to solve. I just thought that if I will just do all of them together, the viewer can be more clear in the concept. So now let us have the given data. So the given data of the first one is that these two quadrilaterals are perfect squares and the length of these line segments are 3 and 9, and you have to find the combined area of these two squares. In the second one, these four are perfect squares and out of which this and this are congruent, and length of this line segment is equals to 2. What you have to find is the combined area of this square and this square. And the third one, this rectangle and this rectangle are congruent to each other, and the diagonal of one of the rectangle is equals to 8. And you have to find the area of this complete figure, that is the area of these two rectangles plus the area of this square. So let us see the solution. So first of all, we are going to see the solution of third one. So in the third one, we can see that these two rectangles are congruent and there is a square, and the diagonal of this rectangle is equals to 8, and we have to find the area of this complete figure. So the first step while solving a geometrical question is that we will mark the side lengths and all the required things. So first of all, the length of this rectangle is equals to y, let it be equals to y, and the breadth of this rectangle, let it be equals to x. So as it was given that yes, this rectangle and this rectangles are congruent, so as first one is having a length equals to y, so second one will also have the length equals to y and its breadth will also be equals to x. Now if this is also the breadth of this rectangle, this is also the breadth of the rectangle and it is equals to x. And this complete length is the length of this particular rectangle and it is equals to y. So complete length is y, some part is already equals to x, so the remaining part, that is this much part, will be longer minus the shorter. Longer is y, shorter is x, so it will form y minus x, that is longer minus the shorter, so it is y minus x. The side length of this thing, so this is also equals to y minus x, this is also equals to y minus x, and that's also equals to y minus x because it is a square. So the first step, that is marking of the variables, has been done. Now the second step. The second step is that whatever line segment has given, you have to just have it in terms of the variables you have just considered. In these three, you can just have a common note that three random line segments are given with particular lengths. So similarly over here, that is having a length that is equals to 8. So what we have to do is bring that 8 in terms of variables you have just considered. So here's the variable considered are x and y. So as 8 is the diagonal of this rectangle, so we can very nicely have that the base square plus the height square gives me 8 square. So from there I have that x square plus y square is 8 square, that is equals to 64. So keep this equation as it is, whatever you will obtain. Now the third step. In the third step, just write whatever things you have to find. Here we have to find the area of this complete figure. So let us do that. So area of this complete figure, so I'm just writing area of the figure. So area of the figure is equals to area of these two rectangles. So area of one of the rectangle is length into breadth, that is x into y. And the other one is congruent, so it's also going to have the same area, that is x into y. So plus x into y. Now plus the area of the square. Area of the square is equals to side square. Side of the square is y minus x, so it will form y minus x the whole square. Now let us solve this equation. So here we have 2 times xy, and opening this with the identity gives me x square plus y square minus 2 times xy. Let it be clear, yes, minus 2 times xy. Now we can clearly see that plus 2xy minus 2xy got cancelled out. What we get is x square plus y square, and that is the area of this complete figure. So I'm just writing area of this complete figure. So I'm just drawing that figure over here. Yes, area of this complete figure is x square plus y square. And remember the first equation, that x square plus y square is equals to 64. So instead of the value x square plus y square, I can have the value 64, and that's the answer, that area of this complete figure is equals to 64. Yes, all we did is the 3 steps. First step, mark the variable. Second step, whatever line segment has been given, have that in terms of the variable, and in the third step, just formulate the equation of whatever given thing has to be found. So now we are going to solve the first one. So in the first question, we have these two squares and we have to find the area of these two squares combined together. So first step, mark the variables. So first of all, let the side of this bigger square is equals to x, so that is also equals to x, this is also equals to x. And now the side of this smaller square, let it equals to y, so this is also equals to y, that is also equals to y. Now the second step, have that particular line segment in terms of the variable you have just considered. So as this is a 90-degree triangle, so I'm just drawing the triangle over here. So this is the triangle I am having. This is having a length that is equals to 9. This side is equals to x, and the base is equals to x plus y, that is x from here to there, and y, that's from here to here. So that base is equals to x plus y, and its hypotenuse is equals to 9. So by the Pythagoras theorem, I can have that x square plus x plus y the whole square is equals to 9 square. So from here I will get that 2 times x square plus y square plus 2 times xy is equals to 81. Okay, this is the first equation we have got, and where we will get another equation by just having this line segment of 3 in terms of x and y. Now here we again have a 90 degree because of the square. Now that right angle triangle over here, yes, 3, this is the 90 degree. Now this base is equals to side of the smaller square, so it's equals to y, and its side length is going to be like y minus x minus y, because this is complete side length of this bigger square, that is equals to x. Some part of it is already equals to y because it is the side of the smaller square. So the remaining part, that's this one, is going to have the length longer minus the shorter. Longer is x, smaller is y, so it's going to have that is length, that is x minus y. So the side of this is equals to x minus y. So again by the Pythagoras theorem I can have that y square plus x minus y the whole square, and that is equals to 3 square. So from here I can have that 2 times y square plus x square minus 2 times xy is equals to 3 square, that is equals to 9, and this is our second equation. Okay, now what thing we have to find is that combined area of this and this. So combined area, so I'm just writing it over there, area of this complete figure, that is somewhat like bigger square and smaller square. So the side length of the bigger square is x, so its area becomes x square, and the side length of the smaller is y, so its area form y square. So ultimately we have to find the value of this equation, that is x square plus y square, and we can do that adding first and second equation very carefully. Look in that equation. So I'm just adding equation 1 plus equation 2. So equation 1 is 2 times x square plus y square plus 2 times xy, and equation number 2 is y square plus, yes, it's 2 times y square, sorry, 2 times y square plus x square minus 2 times xy, and that's 81 plus 9, that's equals to 90. So from here I can see that plus 2xy negative 2xy got cancelled out. 2x square plus x square 3x square, y square plus 2y square 3y square, I can take 3 common, so 3 times x square plus y square is equals to 90. So from here I get that x square plus y square is equals to 30. Now as x square plus y square is equals to 30, and the required thing, that area of this combined square was x square plus y square, and I found the value of that particular equation, and that's equals to 30, and that's our answer, that area of these two square combined together is equals to 30. Here the method was that these steps were very clear, that finding the variables, then that particular line segment in terms of the variable. But as in the first one, whatever we did, we get that as the thing directly. But here we have to just have a nice observation skill, that adding these two equations just cancel out 2xy, we will have this kind of equation, x square plus y square. Before writing down in the paper, you can just think in your mind. So 30 is the answer to this. Now this middle one, that's quite, we can say, challenging than this both. Means just compared to this both, it's challenging, but it's very easy. So doing that over here, so here it is given that this and this square are congruent, but here we have to not find the area of this complete figure, but we have to find the area of this plus this. So let us do that. So first of all, just marking them as the variables. So let the side of this bigger one is equals to x, and that is equals to y, and as these two squares are congruent and they are not needed as much, so let it be equals to a. So this is also equals to a, this is also equals to a, that's also equals to a, all this is equals to a. This complete length becomes x plus y, because this is the side of the bigger one, this is the side of smaller one, so that's equals to y, and that's equals to x. So we have that complete length x plus y, and that same line is again having a length that is 2 times a, so that is equals to 2 times a. So from here we have that a is equals to x plus y upon 2. So a is having a length that is x plus y upon 2. And remember that this much length is going to be a, because it is the side of this particular square. So this much length is equals to x plus y upon 2, and that's from this point to this point. And this complete length was having x plus y, and some part is, that's half part is x plus y by 2. So this much part is also going to be x plus y by 2. And in this we can again see that this much part is equals to y. Now this remaining part, that's from here to here, it will be what? Longer minus the shorter. The longer is having a length that is x plus y upon 2, and this shorter is having a length that is equals to y, so we have to just subtract. So x plus y upon 2 minus y gives me x minus y upon 2. So x minus y upon 2 is the length of this. Now the second step we have to just do, the second step is that we have to just make that line segment in terms of x and y, means whatever variable we have considered. So we can do that in this particular right angle triangle. This all angles are 90 degree because they are squares and rectangles respectively. So in that particular right angle triangle, we have that this side is equals to x minus y by 2. Let it be clear, I'm just zooming it over there. Yes, so we have that particular right angle triangle on this spot. This is equals to 2. This is equals to x minus y upon 2 this side. This is the 90 degree and that is equals to a, and remember a is equals to x plus y by 2. So x plus y by 2. Now we can just apply the Pythagoras theorem. So we get that x minus y by 2 the whole square plus x plus y upon 2 the whole square, and that's equals to 2 square, that is 4. So from here we get that x square plus y square upon we can say a common LCM is equals to 4 because 2 square is 4 plus 2 times xy plus x square plus y square minus 2 times xy. So from here we can see that positive 2xy and negative 2xy got cancelled out. X square 2x square y square 2y square. So taking 2 common and cancelling the 4 in the denominator, we get that it will form x square plus y square upon 2, and that's equals to 4. So from here we will get that x square plus y square is equals to 4 into 2, that's equals to 8. The second step is also done. Now the third step, whatever thing we have to find, just write it down in the terms of, write it down in the equation. So what we have to find is the combined area of this square and that square. So as the side length of this square is equals to x, so area, writing it over there, area of the complete figure that is looking like this square and that square. So area of this complete figure is x square plus the area of the smaller square, and the side of the smaller square is equals to y, so its area forms y square. And just look, we have just found the value of x square plus y square is equals to 8. So the area of this complete figure becomes x square plus y square, and that's equals to 8, and that's the answer to this question. So these 3 questions were very easy and very nice to be solved. So here's the first one, I'm just dividing it from here. Yes, this is the first one in which there was like find the equations and just simplify this equation so that's to get the answer. In the second one all the things were direct, and in the third one also we can see the third one was the most simple one. It's very like easy and fun to do. So these 3 geometrical problems were like similar to each other, having the same strategy, so I just thought to do them together so you get better in the concept. So the answer to the first one is equals to 30, answer to the second one is equals to 8, and answer to the third one is equals to 64. And I think these are the most simple way to solve these 3 questions, but still I will just love to see your solution. If you have any other method, do comment below, or else you can DM me on my Instagram, link is in the description. When someone gives a better solution to the same question and we can show it to your viewers, it spreads the knowledge.